Hello, in this video we are going to do a basic introduction to the AVL tree, which is one of the self-balancing binary search trees. So AVL tree was invented actually more than 50 years ago, and it was, like we just said, one of the self-balancing trees. It was in fact the first self-balancing binary search trees. And the three-letter AVL is named after the author. I can't say their name, right? So I'm not going to say it. They're from the Soviets, and here is a link to the wiki page if you like more history about AVL trees. Um, anyway, so AVL tree, well, it is a binary search tree. Okay, now, in addition to all the invariants of a binary search tree, it has this requirement that for every one of its nodes, the left subtree and the right subtree must differ in their heights by no more than one. So maybe both trees are exactly the same height, and that's good. But if they're different, they cannot be different by more than one. So if you look at this constraint, then you kind of think, well, why not make both trees exactly the same height? Why allow them to be different? Well, we'll get to that in a bit. But let's look at first of an example. So given that definition that we just read, look at this tree. Is this an AVL tree? And if you need a little hint, remember how we calculate heights. It's from the bottom up. Okay, so here is how we would go about checking if a tree is a AVL tree. So we start at the bottom. Remember the height at the leaf node is 0. Some literature actually starts at 1. It doesn't matter. Just stick with one definition. So we start at 0, and as we go up, this node will be at height 1. This node will be at height 0 because it is the leaf node. Now, when we come to the node 8, then the left subtree is height 1, the right subtree is height 0. Then we take the max of the two, right? Remember, the height is the distance to the deepest node. So the height of node A would be the highest subtree, which is 1, plus 1 more, right? Which is itself. So the height of 8 is, node 8 is 2. So we come up here, then the left subtree's height, left subtree of 10 height is 2. And then we do the same thing on this right subtree, and we arrive at, this subtree also has a height of 2. So yes, this is an AVL tree because both subtrees have exactly the same height. All right, here are two other trees. Are these AVL trees? So pause the video, think through this, and see if both trees satisfy the AVL tree invariance. And here's the answer. So the one on the left is an AVL tree. There's not a single node of it has violates the constraint that the left and right subtrees height is differ by more than one. However, this tree here is not an AVL tree because if you look at this tree, the height is 2. Okay, and the right subtree, the height is 0. So the difference between 2 and 0 is 2, and that's more than 1, which means the node at the root node um, does not satisfy the AVL tree's invariant. So here is another question for you, that if a tree's root node or a BST's root node, both its left and right subtree have the same heights, is this tree an AVL tree? So think about that. Well, the answer is no. It's not enough for just the root node to satisfy the invariant. Remember, the invariant is every single node must have left and subtree whose height differ by no more than 1, right? So you can look at an example here. Here, the root node has both the left and right subtree, they're the same height. However, if you look at some other nodes, for example, the ones that the arrows are pointing to, for example, this one, right subtree is height of 1, the left subtree, there's no subtree. So basically, there are 2 levels on the right subtree and there's nothing on the left. So it differs by more than 1. So, right, so this kind of tree is not an AVL tree. Okay, since we're in the mood of just thinking about what are AVL trees, is this one an AVL tree? Well, as it turns out, you can try to go through every single little node and see if they satisfy the invariant, and as a matter of fact, it does. Every single one of them, the left and right subtree height differ no more than 1. And as a matter of fact, this is the smallest possible AVL tree that you can come up with for the height of 9.